Great. So, good afternoon, everybody. Welcome to our CISR seminar. Today, we have a great speaker, one of our new faculty at WSU, Shu Lin. She's assistant professor in the School of Electrical Engineering and Computer Science at WSU. Her research interests revolve around web security and privacy, with a recent focus on investigating online tracking techniques and tackling pitfalls in authentication mechanisms. Her research aims to explore the web's threat landscape and develop countermeasures to protect user privacy. Her work has been published in top-tier security venues, including S&P, USENIX Security, and CCS. So I'll turn it over to her to get started and remind everybody to feel free to put questions in the chat.
Thank you for the introduction. Feel free to interrupt me if you have any question. So I'm going to talk about picking through the keyhole, exploring web-based privacy-invasive attacks. Currently, we all use internet in our everyday life, and we chat and have meetings with people online. We manage our bank accounts online. And however, we also expose ourselves to security and privacy threats during our online activities. So what are those threats? Here is our research. We break and fix the web. We analyze the online systems, mechanisms, and protocols. We mainly focus on web browsers and web applications. And we discover unknown vulnerabilities, and we demonstrate novel and practical attacks that exploit these vulnerabilities. And this is the part of break the web. And to fix the web, we disclose our findings to affected online systems to help major companies to fix the bugs. And we also develop countermeasures to prevent these attacks to better protect the users. So today I'm going to talk about privacy-invasive attacks that abuse browser features and browser fingerprints. And currently, browsers and web applications are introducing new techniques to improve user experience. And however, they may introduce new bugs as well. So I'm going to talk about 3 research works. The first one is the privacy threats of browser feature, browser form autofill. And I believe most of us have used this form autofill functionality. So on some websites, we need to fill out our address and our payment information. So it's tedious if we have to fill out the same information over and over again. For this reason, browser provide this form autofill functionality. They save our information in the browser. So if we need to fill out these online forms, we can simply click on this field and trigger this autofill profile, which is browser created for us. And once we trigger this feature, a browser will automatically populate these values for us. So we don't have to manually input this information. And this feature is very handy. However, malicious websites can abuse this feature to steal our sensitive data without our knowledge or consent. So here I'm going to demonstrate 2 types of attacks that abuse this feature. The first attack is the stealthy data exfiltration. So let's look at this website, and this website looks innocent. And at the top of this website, it requires the country information, which is not sensitive at all. So I click on this field and I use browser autofill to input the country information. And everything looks fine. However, this web page has additional hidden fields that require more sensitive information, including name, including my company, phone number, and email address. So once I use autofill to input the country information, I also give away all my sensitive information here to the website. So next we wonder if this is common for the website to have all these hidden form fields, and what is our browser's behavior against these hidden fields. So we used two major popular browsers, Firefox and Chrome, to test the top 100,000 websites. And surprisingly, we found 24% of these websites have the hidden fields, and they can be autofilled by Firefox. And this number for Chrome browser is 5%. While Firefox has higher number, but it displays a message showing what type of information can be autofilled by Firefox, so it's better. So next, we want to know what types of information are exfiltrated by these hidden form fields. We can see the result include a variety of types of information. There are some generic types, such as country and state, but some sensitive types, such as our home address, full name, and phone number, are also highly targeted. So some people might say, well, I'm very cautious and I'm not going to use this autofill feature. I will manually type my information into the online forms. So are these people safe? Here I will introduce this autofill preview feature. So as soon as we click on this online form, if we have an autofill profile, browser will show all the values in this form if we use autofill feature. So if we don't want to use autofill feature, simply click outside, all these values are gone. So these values are never populated into the form and they are not accessible to the page. Website cannot access these values. However, here is I'm gonna demonstrate the second type of attack, which is data inference attack. Use this attack, websites can actually invert the user's values without triggering autofill. So it runs when user click on a field and the values are previewed. So the websites can invert what are the user's sensitive value in the profile and what exact values they are. So I make a demo to show this data inference attack, how it works. First, I manually save a user's credit card number in the browser. So once this victim visits the website, simply click on this field without triggering autofill. After a few seconds, this website gets the exact credit card number of this victim. So we get this credit card number. So what is happening on this page? If we show the hidden fields, I actually hit a large number of candidate credit card numbers on this page. So I have 100,000 credit card numbers hidden on this page. So as long as one of the values matches the user's credit card number, then the website can invert the user's credit card number. And even worse, we can have an arbitrary number of candidate values in a page, and these values are invisible to the users. And so this is data inference attack. Without triggering autofill, we can still invert the user's sensitive information. So next, we disclose our findings to the affected browser vendors, and Google fixed these vulnerabilities based on our report. So on their newer version of browsers, they are not vulnerable to this attack. And next, I would like to talk about the privacy threats of browser fingerprints. This attack exploits the authentication pitfalls. We know that our online accounts are valuable targets for attackers. So attackers can trick us into visiting a phishing website to collect our credentials, and they can use these credentials to log into our account. And to prevent this attack, two-factor authentication is critical. It requires additional verification, such as a verification code sent to our cell phone. So this 2FA actually prevents more than 90% of phishing-based hijacking attempts. However, from the user's perspective, if we are required to solve a 2FA challenge for each login attempt, it's not convenient. It creates friction. So certain websites have this remember this device feature. So if a device for each login, if the device is the same device from the previous legitimate login, 2FA challenge is not present. If the two devices are, if the device is different from the previous legitimate login, then this login attempt is considered as a suspicious login, and it triggers 2FA. Currently, some websites started to use browser fingerprinting technique to remember a device. So what are browser fingerprints? Browser fingerprints are device information that can be collected by a website from user's browser. And it includes various device characteristics, such as the operating system, the browser type, the language, the time zone. And if we combine all these pieces of information together, we may be able to uniquely identify a specific user or device. And browser fingerprints can be collected by any website using JavaScript APIs without any user interaction. And so some advanced risk-based authentication systems use browser fingerprints to remember the user's device. And in this system, when a user visits a login page, the website sends the fingerprinting script to collect the user's fingerprints. And users input the credentials, and their device fingerprints are collected by this website. So if this fingerprint is different from the previous login, it triggers 2FA. A user has to solve this challenge. if the fingerprint matches the previous login, then 2FA is skipped. The user can successfully directly log into their accounts. So in this authentication mechanism, from an attacker's perspective, what can they do to track the websites into not presenting a 2FA challenge? So in this system, websites learn about the user's device from the JavaScript API, and they remember the device using the device fingerprints. So if somehow we can replace the attacker's fingerprint with the user's fingerprint, then we can trick the website into thinking this login is from the legitimate user, and 2FA can be skipped. So this is our threat model. We assume that the attacker can trick the user into visiting a phishing website and entering their credentials and collect their fingerprints. So here is an overview of our attack workflow. It has 3 phases, and we developed 2 browser extensions to automate this process. And next, I will talk about each phase. In the first phase, attacker will use the first browser extension, fingerprint extractor extension. So attacker visits a target website. The target website sends a fingerprinting script to collect the attacker's device fingerprints. And our extension automatically replicates the fingerprinting process of this target website, so the attacker can extract the fingerprinting code of this target website. So in the next phase, attacker have all these fingerprinting code of the target websites. They can build a phishing website using this fingerprinting code. So once the user visits this phishing website, the page generates fingerprints of this user's device for all these target websites. And after this phase, attacker have the user's credentials and have the user's fingerprints for the target websites. So in the last phase, attacker is ready to perform this attack. Attacker will use the fingerprint spoofer extension. First, attacker visits their target website. Still, website sends a fingerprinting script to try to collect the attacker's browser fingerprint. And this extension replaces attacker's fingerprint with the user's fingerprint. And because this fingerprint matches the user's profile, the 2FA is not present. The attacker successfully bypass 2FA and access the user's account. So here we make a demo to show we spoof device fingerprints. We have the device to visit a popular fingerprinting website, so we can see all those fingerprinting attributes and their values. So the left window is the victim's device, and the right is the attacker's device. And we can see because they are 2 different devices, the fingerprinting values are so different. All these attributes are different. So next, we enable the fingerprint spoofer extension on attacker's device, and let's visit a website again. So now we can see the extension spoof the attacker's device fingerprints and make it look exactly same as the victim's device. So this fingerprinting website will think that this attacker's device is identical to the victim's device. So next, we would like to know if our attack is feasible in the real world. So we perform our attack on real-world systems using our personal accounts. Basically, we have two devices. The first device, we use this device to log into a target website system as a normal user. And the second device is a new device. It never logging into this target website before. So we would like to know if we can bypass 2FA using this attacker's device. So we perform this attack on these 14 websites. We can see many of these websites are critical financial online services. And these are the fingerprinting attributes that use for authentication. And we successfully spoof all of these fingerprinting values. And we completely bypass 2FA in 9 websites. The only reason that our attack is prevented is the IP restriction. And even in this case, we can still bypass some of them by modifying their headers. So what about phishing websites in the wild? We know that phishing websites are trying to steal our credentials. Are they collecting the fingerprints too? So we started 3 phishing website dataset for over 3 years. And we can see for those phishing websites that running JavaScript, the majority of them are collecting fingerprints, and this number is increasing over time. So next, we want to see if the phishing websites have all necessary fingerprints to bypass 2FA for the target websites. So we look at the phishing websites that target our testing websites. And this is the number of phishing websites. And this is the number of phishing websites that have all necessary fingerprints to bypass 2FA. So if we look at Band-Aid's data, we can see more and more phishing websites that try to steal Band-Aid's credentials are capable of bypassing Band-Aid's 2FA. And this figure shows the number of phishing websites that target 2 banks. Band B is not vulnerable because it has very strict IP requirement, and Band A is vulnerable to our attack. And we can see there is a big drop in Band B's data. So it could be due to the IP restriction, and Band B is not vulnerable to this type of attack. And for Band A's number, we can see the number of phishing websites that target Band A is steadily increasing over time. So it's possible that phishers are adapting their targets. And we disclose these findings to the affected vendors, and we notice so far some companies change their mechanism. They require 2FA for each login attempt. It's more secure, but it creates friction for users. And some websites change their mechanism by removing fingerprinting technique for authentication. They went back to use cookies. However, cookie-based authentication is vulnerable to cookie hijacking attacks. So there is a need for developing fingerprint-based authentication mechanism that is robust to this type of attacks. And this is a interesting future direction, and we are actually working on this. And the last work I would like to talk about is still about browser fingerprinting, but in this work, we developed a new fingerprinting system that is completely different from the traditional fingerprinting system. And so we know that websites can use JavaScript to collect the user's device information and generate the user's fingerprint to track this user. So popular browsers have recently adopted a series of defensive countermeasures that mitigate browser fingerprints by block certain APIs. So they may also disable JavaScript entirely or partially. So there's no way for the online tracker to collect the fingerprints. So in this way, they can better protect the user's privacy. So as the tracker's perspective, they may be thinking, is fingerprinting possible without JavaScript? Can we use anything, something else? So here is our approach. We develop a new browser fingerprinting mechanism, and it doesn't use any JavaScript. Instead, it uses styles. It still provides highly discriminating fingerprints. This system is based on the observation that different devices render these page elements differently, where it's usually hard to tell the stylistic differences with our own eyes. It's sufficient to distinguish between the devices. So what can we use to detect the stylistic differences? We will use the dimensions. So in our system, we have a variety of fingerprinting elements on the page, and all these elements are invisible to users. And based on their dimensions, we can learn a lot about the user's device. We can learn all these attributes. Some of the attributes are already existing in traditional fingerprinting systems, and some attributes are newly introduced by our system. So here is how our fingerprinting page look like. Again, this is completely transparent to users, so it doesn't affect the user experience. It doesn't affect the website's functionality. So we have these fingerprinting elements aligned with iframes on the page. If a different device visits this fingerprinting page, the dimensions will be different. So based on their dimensions, we can distinguish between different devices. So here is our fingerprinting process. When a device visits our fingerprinting page, we collect all these elements, dimensions, and based on this dimensional data, we generate an identifier to uniquely track this, identify this specific user. So next, we want to see if this new fingerprinting system effective against anti-fingerprinting browsers and tools. So we test our system with privacy-focused browsers and extensions and detection tools. And we found that the majority of our fingerprinting features are still effective. So our system is able to bypass the protection offered by these privacy-focused browsers, extensions, and detection tools. And if we use traditional fingerprinting system, because they are using JavaScript, so most of the features are not effective. And next, we would like to access the new fingerprinting system's capability to track, to identify the devices. So we conducted a large-scale pilot study. We deployed our system on 3 IBM internal portals for over 2 months. And for comparison purpose, we also deployed Fingerprint.js, which is the popular state-of-the-art fingerprinting library. And it's noted that the devices in this environment are very challenging because the device population is heavily skewed towards more specific homogeneous models. We break down the results into different browser types, and we can see even our system doesn't use any JavaScript, simply use the styles. Our system still have sufficient discriminating power. And if we look at the privacy-focused browsers, our system actually outperforms the traditional fingerprinting system. So here is our new fingerprinting system. It doesn't require any JavaScript, and it still provides the comparable discriminating power to traditional JavaScript-based fingerprinting system. And more importantly, the new fingerprinting system can effectively bypass state-of-the-art anti-fingerprinting defenses. So we report, again, we report this privacy issue to the browser vendors, and we're helping them to fix this issue to better protect the user privacy. So if you are interested in breaking and fixing on the web, please feel free to contact me. And thank you for listening, and I'm happy to take questions.
Great. Thank you very much. I don't see any questions in the chat. So someone, Noah Black raised his hand. Noah?
Oh, hi. Can everyone hear me?
Yes.
Oh, wonderful. Browser security interests me greatly. Thank you for the presentation. I appreciate it. My question is so the autofill, that's fascinating. So it would just give it just on any invisible field just automatically. That's crazy. And your new method of doing it does not require any JavaScript. I was curious if that is, yeah, that pixel generate. That's very fascinating, especially with browsers that give users the false sense of security of not enabling JavaScript. It's very. I was curious if. I was curious if you could elaborate on that identification method a little bit more.
So you're asking the fingerprinting system that doesn't require JavaScript?
Yes.
Yeah. So we use only HTML and CSS. And look at this page. So because So each element has a specific dimension, like width and height. So when a browser render these elements, so their size, all their sizes are affected by the underlying device characteristics. Like some elements can be affected by the operating system's language, and some elements can be affected by user preferences or the font size. So based on this, if we use CSS media query to automatically prop the dimension of these elements based on the iframes dimensions. So on the server side, without JavaScript, we can still get all these elements dimensions in real time and use that to generate an identifier to track the specific user. Did I answer your question?
Oh, yes. I was just confused how the server got that information. But yeah.
Right, we use the CSS media queries. Yeah, I skipped the part because it takes a lot of time to write that, but we can go offline. Thanks for your
It's very
question.
fascinating. Thank you.
Asifa, do you have a question? And then I want to
Yes,
do.
I do. Thanks,
David.
Shuli. That was a very interesting talk, and I enjoyed your animations. They were cool animations all over the place. I've got two quick questions. The first one is very quick, so I will start with that. The autofill, right? If you were to populate what the autofill would say, you would be more vulnerable. And you said, would you be safe if you don't do that? You click outside and you got a clean one, which is what I do all the time when I have things to fill out. But then I didn't catch you say that. Was the conclusion that you're not safe? Is that what you say? Even if you have cleared up and you clicked outside, you are still not safe? Is that what you said?
Right. So even you don't use autofill feature, you manually type, but as long as you click on the fill, you preview the features, you preview those values, and then the website can still infer the exact values. So even without triggering autofill, they are still not safe.
Right. That's what I suspected, but wanted to hear. My other question is, a lot of the things that you do is about web, right? And you can view the web links between pages, and you can think of it as one big graph, and that's where many interesting things would happen, including search and so on. So, is there anything that you do, maybe something that you didn't talk about today, where you benefit from looking at the web as a graph, where these issues of security and privacy could be seen? I was not sure if there was any example from what you talked today where looking at the web as a graph is a helpful tool. Do you have any work or anything to say around that?
Saying using web as a graph.
Where the nodes are web pages, and whenever you have a link, you have an edge between them. That view of the web, is it related to any of the work that you do that's about privacy and security? No? It's okay if it's not.
Can you please repeat the question?
Yeah, so maybe, and I think I get the answer indirectly by you not having to see this. I was just curious if there was any connection from what you did, but I'll skip that. I think there are other people who have got questions, so thanks.
Bernie?
Yeah, so I hope you're hearing me. My question is similar to Asifa's. In the time frame that it shows you the autofill and the time you click off, in that moment, can it intercept your information, or do you have to approve it before it actually can compromise your information?
Yeah, I think I skipped to many technical details. Let me see other specific. Yeah, so oh, um, so actually when we when we click on this field and preview the values, it's a side channel attack. There is a side channel linkage because when we preview these features, if we have a drop-down menu on the page, the drop-down menu that includes the user's value as an option will have different styles. For example, they will change the background color. So we just need to inspect the background color or the specific style changes, then we can infer which option, which drop-down menu actually includes the user's value. So we actually replicating values across multiple menus. So for example, if we observe the drop-down menu B has the style changes, then we can infer value 1 is the user's value. And if we notice drop-down menu A and C have these style changes at the same time, so we can infer the value 4 is the user's value. So we use this technique to perform a side channel attack to infer the user's value.
Thank you.
Hi, this is James Crabb here. I have a question about the 3 phishing site data sets you mentioned that you used earlier. I was just curious if you could tell us a little more about those data sets, their sourcing and the differences between them.
These 3 phishing websites, the first 2 phishing websites are from a paper. They publish their data sets, and the third website is from this APWG. And so the first 2 phishing websites, we have only the source code, so they are not alive. We use the source code to rebuild these phishing websites on our local server, and then we visit this phishing website locally. And for the third data set, because it was a more recent data set, and all those phishing websites are still alive. A lot of them are still alive. So we just directly visit those websites online, and then collect those their JavaScript execution traces.
Okay, yeah, interesting. Thank you.
There are a couple questions, Noel, on chat.
Yeah, I didn't unmute myself, so I was asking them and you couldn't hear me. So one of the questions is, can your work be described similar to cyber forensics?
It's related, but cyber forensics is more about extract the digital evidence, and we mainly focus on demonstrate novel attacks, and we prevent these attacks. Yeah, so it's related but different. Yeah.
Okay, the second question is kind of, what are the differences between these kind of malicious attacks on mobile apps versus a Windows, Mac operating system apps? Similar to, do these autofill fingerprint malicious attacks apply to both mobile apps as well as web attacks?
Right. Yeah, this is a good question. For autofill, we mainly focus on desktops. Mobile devices have their own behavior, so autofill attacks apply to only desktop computers. But fingerprinting applies to mobile and desktop devices. So as long as we have the browser, then the website can collect the fingerprints. And even our new fingerprinting system also works for the mobile devices like iPhone, Android. We're testing in different types of mobile devices, and they actually work. And actually, they do because the mobile devices are so different. So the performance is even better than the desktop devices. Yeah.
All right, I think we're running out of time. Any last minute questions? I do want to remind everyone that's attending to please, particularly the students, to fill out the survey link that's in the chat for as part of our evaluation of our seminar series. So, all right, I don't see any more hands or any more text or in the chat. So let's thank our speaker very much for her presentation.
Thank you.
Thank you.
Thank you. Good job.
Thanks, you.
Thank you.
Thank you all.